Hi there, this is Jacob Nash, Algebra Lessons. This is Unit 3, Lesson 7 on complex number systems. I've not made that much videos lately because I've had a lot of work, so that's why. But this is a very long unit, and I've planned out all the videos, and there's going to be 17, and that's longer than there's ever been in any unit for geometry or engineering that I've done in the last year. Okay, so what is complex number systems? Well, hopefully in Algebra 1 you learned about real number systems, but I can't go through that right now because that's not in the standards. But basically what it is, well, I guess I kind of am going over, but just the basics. There's rational and irrational numbers, but there's also non-real numbers, and that's what the complex number system is. And it is complex, that's why they call it that. So complex numbers are ones that aren't something that there actually can be, and that's if you have a square root of a negative number. So let's say square root of 1, that's not something that there is, so not possible. And what you represent any number like this with is I. It kind of looks like a 2 with a dot on top of it. That's what kind of I it is. And for some reason, for certain purposes, you need to be able to simplify expressions that have this variable I in it. And it's a little bit different than if it's an X, because here's how it's different. So you treat it like if it's an X or any other variable, usually, but if it's squared like this, that means that you just replace it with a -1. That's the only thing. So there's 5 different things that you have to do. You have to add them, subtract them, multiply them, divide them, and do radicals with them. So let's start with addition. So let's say we have 4 plus 2i minus 3i plus 1. So how would you simplify that? Well, it's just like if it was an x, because there's no squareds, so we don't replace it with a -1. So you combine it. 2 minus 3 is -i. 4 plus 1, 5. There you go. That's simple. That's all it is. Then subtraction is also the same as if it was a different variable. So how about we have, let's do this. 2 plus 5i minus, in parentheses, 3 plus 4i. So what happens? You know, when there's a negative outside of parentheses, you distribute it. So you now have 2 plus 5i minus 3 minus 4i. So it just changes the signs. And then, just like with addition, we combine like terms. 5 minus 4, just I. 2 minus 3, minus 1. So that's what it would simplify to. Multiplying is mostly the same also. You just do something called foiling, which I don't know if I've said before in a video. So 3i plus 2 times 4i plus 1. So what do you do when you FOIL? Well, it's an acronym, FOIL, and it's kind of the same as if you did the box method, where you have something like this, and but this is kind of something that's more professional to do. So if you've done that in middle school or elementary school, I don't know what it's like, but then this is something that's better to do, kind of. I mean, it doesn't matter. You still can use that, but F means first. So the first terms are the ones that I'm doing in red. First terms in both of those parenthesis sets. So 3i times 4i would be 12i squared. Remember, I squared will change to a -1, but we're not doing that yet. So then we have outer. Outer is the 3i and the 1. That's what that is, because they're in the outer areas of the parentheses. So 3i times 1, anything times 1 is itself, so 3i. Then I is inner. That would be these, inner. And then that turns out to be 8. And then last. Wait a second. No, 8i. Sorry, for some reason. Forgot about the I. So last is 2 and 1. 2 times 1 is just 1. Sorry, 2. So then you combine like terms. So 12i squared plus 11i plus 2. We're not done yet because this is where this thing is different than the other variables. So you might be thinking at this point like, what's the point? I already know how to do that. But we need to replace this I squared with a -1. That's what we always do. And just to confirm why is because I means the square. It basically just means a -1 squared if it would turn out to be a -1, and anything squared can't be a -1, assuming that it's in the parentheses. So now we change that to -1, and basically anytime you multiply something by -1, it really just changes the sign, so it just turns to -12 plus 11i plus 2. So that turns out to be 11i minus 10 when you combine -12 and 2. So that is what this is simplified. So that one's a little bit harder, but if you don't like that, then you might not like the division one where you have to multiply anyways. So here is division. So let's say we had 5i minus, we'll actually put it this way. 5 plus 3i and 2 plus 4i. What is that going to be? You might think, oh, 5 divided by 2, 3 divided by 4. No, that's not what it is. You have to do something. So here's what you do. You have to first multiply the denominator. Hopefully you know that's the bottom part of the fraction. I mean, I think you probably know that. But you multiply it. You keep the one without the I, that term, the same sign. But you change the sign of the part with the I. So now it's -4i. So we multiply that by that. And we multiply the numerator by that. So that's what you do. Which means you have to multiply this using the foiling method and this, which is what we just did. And so let's do that. So first is 5 times 2, which is 10. Then, okay. Then, outer, -20i. Inner, 6i. And then last, minus 12i. First, for the bottom one is 4. And then outer, -8i. Inner, +8i. And then last is going to be negative. Wait a second, I did something wrong. 12i squared, that's what that is up here. And then 16i squared. So why do you have to do this thing where you change the sign? Well, if you do that, that will automatically make it have i's that cancel out, which is what you need. So now we simplify this over here. We have 10 still, then -20i plus 6 is going to be -14i. And then remember, I squared means -1, so now that's -12 times -1, which is just +12. That's the top. On the bottom, we have these that cancel out, so we just have 4 minus, well, it's actually going to be plus because we changed that, and it will be plus 16. So further simplify that, you now have, it's going to be 22 minus 14i divided by 20. That is our answer. That's how you divide. So that was our fourth one. The last one that you have to do is simplifying radicals. So let's say we had square root of, how about, I don't know, just random number. Right now it's, well, I'll just do 31. Let's see. Might not be a good choice. -31. If it was 31, then you would just simplify it by normal radicals, which you learned in Algebra 1, hopefully. But when you simplify radicals, you break it into parts at which you see what two things multiply to equal 31 in this case. And is one of them something that you can take the square root of? If so, then you do that. If not, then you just keep it like it. So let's see. What things can multiply to equal 31? Nothing, except for 1 and 31. And if you take the square root of 1, it's still 1, and which would mean that this thing doesn't even change. So 31 is a bad choice. I should have known that that was prime. Let's do a non-prime number. How about 63? So if it was 64, obviously that would turn out to be, well, if there was no negative, it would just be 8. But that 63 it's not a prime number, and so it can be broken down. Let's see. Well, maybe not into square roots. So how about let's do 48. That's a common one that you might see on problems because there is one that can be. So think of the things just like when we did factoring. What things multiply to equal it? 1 and 48 can, 2 and 24 can, 3 and 16 can. Well, we can just stop there. Are any of these something that you can take the square root of and it will be even non-decimal number? 16, we know that. So now we break it apart, and now we have 16 times 3. And now you take the square root of that, and you have 4, but you have an I, because remember, we still have the negative 1. So that's how it's different than when there's no negative than if there is. And then you still have the 3 left over, which you can't take the square root of, so then it's just 3. So this one's a little bit tougher, so that would be the answer of this. Let's do another one just so that, make sure that you understand what it is. So let's see. Let's do 27. What things can, well, there's lots of things that can multiply to equal that. Well, not a whole lot, but one example is 9 and 3. You can take the square root of 9, so you get 3, but remember, there's an I there still because of the negative. And then 3, once again, is outside. So that's what it is. So that's it for this lesson on complex number systems. That was lesson 7 of 17. So see the next lessons on quadratics.